Hey everybody, these are the notes for section 6.4. This is continuing on talking about radicals in this chapter. In this section, we're going to add and subtract them. So the key to this is remembering that when we add and subtract radicals, we're talking about like radicals. That's how we can add and subtract them. When radicals are like, they have the same index. Oops, where's my pen? And the same radicand. What that means is the same index, the same n here, and the same thing under the radicand. So I could add the cube root of 7 plus the cube root of 7. But I can't add the cube root of 7 plus the square root of, oops, that's not how you write that, the square root of 7. Okay, the cube root of 7 is a thing. You think about it like a variable. So if I had, well, let's see some examples. So here we go. This is 6 radical 11 minus 2 radical 11. So basically I have 6 of the radical 11s, and I want to take 2 of them away. The radical 11s match exactly. They have the same radicand and the same index. They're both square roots. And the 11 is under the radicand. So they match completely. I can subtract. So I have 6 of them. I'm going to take away 2 of them. I'm going to be left with 4 square roots of 11. Same thing here. I have a square root of 3 plus a square root of 3. What I get here is not the square root of 6. Notice up here in the first one, I didn't change what was under the radical. I just changed how many of them I had. So I had 6 of them. Take away 2. Here, I have 1 of them here and 1 of them here. So now I get 2 radical 3. It's because you can write your imaginary ones in if it helps, okay? So try a couple more. 5 square roots of 6 minus 8 square roots of 6. I have 5 of them. I'm taking 8 away. Is going to give me -3 square roots of 6. I have 1 square root of 10 plus another square root of 10. That means I have 2 of them, 2 square roots of 10. All right, let's try something else. In this case, just take a minute and make sure everything matches first, right? This is the cube root of AB. So is the second one, so is the third one. I'm going to put my imaginary one there. It'll help my brain. So I have -2 cube root AB plus 7 cube roots of AB minus 1 cube root of AB. So really, I'm really just thinking about the numbers. -2 plus 7 minus 1. Well, -2 plus 7 is 5. Minus 1 is 4. So what's left is I have 4 cube roots of AB. This one is scarier than it looks, or looks scarier than it is. It's not scarier than it looks. So here, what's under the radical is the same, cube root of, or square root of 3y. And that one. So I'm really just concerned about the numbers. So I can think of it as 1/4 x minus 3/2 x. Well, I'd really just need a common denominator there, right? So 1/4 x minus the common denominator to be 4, so 6/4x. 1/4 minus 6/4x is -5/4 x. Okay, and the radical 3y just comes on the end, so I am left with -5/4 x radical 3y. Okay, all right, try those two. The first one is 5 cube roots of xy minus 3 cube roots of xy plus 7 cube roots of xy. I have 5, I'm taking away 3, and I'm adding 7 more. How many do I have? Well, I have 9 cube roots of xy. For the second one, number 4, I have 5/6 y radical 2 plus 1/4 y radical 2. The y and the radical 2 even, I don't have to pay attention to. They're exactly the same, right? So I'm going to have 5/6 y plus 1/4 y. Well, the common denominator would be 12, right? So 6 times 2 is 12, so 5 times 2 is 10. 4 times 3 is 12, so 1 times 3 is 3. That gives me 13 over 12y. That means that's going to be 13 over 12y, and then I'm going to put back on that radical 2. All right. Sometimes when we have to add and subtract radicals, we have to do some simplifying to make the radicands match. In this case, that's what's going to happen. That's why we simplified first, okay? So if I look at 8, 8 can be simplified. So I'm going to do that. So I have 3 radical. I can break up radical 8 into radical 4 and radical 2. That becomes 3 times 2 radical 2. So 6 radical 2 plus radical 2. Now the radicands match, right? So I have 6 radical 2's and 1 radical 2. That gives me 7 radical 2's altogether. Here, it's a problem, right? They don't match, but maybe they do, because I can't have more underneath the radical, a higher index than the radical itself. So I got to do some simplifying, I think. So let's look at the first one. 8, I have the square root of x cubed square root of y squared. Well, I can break up x cubed into x squared and x, and y squared I'm just going to leave b. So that becomes 8. The x squared, or the radical x squared, just becomes an x. The radical y squared becomes a y. And I keep radical x. Oh, this makes more sense. For the second term, I have 3y minus, I'm going to break up that x cubed the same way, right? Minus 3y radical x squared, radical x. That becomes minus 3y x radical x. Now I have, well, xy and yx are the same thing, right? Multiplication is commutative. So I have 8xy radical x minus 3xy radical x. That means I have 5 of them, xy radical x. All right, let's try another one. Whew, there's a lot to simplify here. So take a minute. Take it one step at a time. Let's deal with the 5th square root of 50 x squared y to the 5th first. I'm going to break up 50 into 25 and 2. I'm going to leave x squared. And I'm going to break up y to the 5th. Let's see, I need something even. Y to the 4th. And y. Okay, I'm going to change colors. That's a 5. That's an x. That's a y squared, right? And I'm left with radical 2y. Okay, so now I'm going to do the second term. It has a 13y at the front. I can't lose that. Radical 2, radical x squared. I'm going to make y cubed into y squared and y. Okay, change my color again. So that's going to become an x. That's going to become a y. So I'm going to end up with 13. I need an x. I already have a y, so now I have y and y. That makes y squared. And I'm left with radical 2y. Okay. And then the last term is that 98. How do I break up a 98 into perfect squares? Well, let's see. Oh, I know. 98 is made up of 49 times 2. 49 and 2, radical 49 and radical 2. Oh, I lost the xy, though. That was in front of them. Even I do that. So let me put that back. xy, radical 49, radical 2. Y cubed, I'm going to make out of what? Radical y squared and radical y. Okay, now break stuff up. Oops. 49 is, square root of 49 is 7. I have an x. This guy is going to become a y. So then I'm going to have 2 y's. That's a y squared. Radical 2y. So now we got to look. The radicands and the indexes match. Radical 2y. And I also have to make sure I'm adding and subtracting like terms when there are numbers and variables, right? So I have xy squared, xy squared, xy squared. Now I can just add and subtract the numbers. 5 minus 13 plus 7. Well, 5 plus 7 is 12, minus 13 is negative 1. So I'm going to get negative 1 xy squared, radical 2y. Fini. You don't need the 1 there. It could just be negative xy squared. That's fine too, if you can think of it like that. All right, you guys try these. The answer for number 5 is 7 radical 3. Make sure you can get there. The answer for number 6 is negative 2 a radical b. And the answer for number 7 is 2y radical 2y. So please take a look and make sure you can do each of these and get each of these answers. When you are stuck, you know where to go into the discussion. All right, let's try to add these. Let's see where we get. So this one is a little bit of a different case. I'll show you why. Let's simplify the radicals first. I got 3 radical 2 radical x. Okay, radical x squared. That's okay. So x squared, radical x squared becomes x, so 3x radical 2. Okay. 8 breaks up into radical 4 radical 2, so that becomes 2 radical 2. Now here's the issue. The radicands and the indexes are the same, right? But the variable isn't, because normally if I had 3x plus 2, I can't add those. That's fine. So what you get is 3x radical 2 plus 2 radical 2, same thing. Alex is going to ask you to go one step further. There is technically a common shared term here. It is the radical 2. So what you can do is factor out the radical 2 out to the front like this. So I have radical 2 times 3x plus 2. That's fine as well. All right, here's the last one. This works the same way, okay? So break down 4 radical 45 first. Let's see, 45 is made up of 9 and 5. That 9, square root of 9 is a 3, so 4 times 3 radical 5 gets me 12 radical 5. All right, now let's look at the second part. Square root of 5, square root of radical 4, y to the 4th, okay? So radical y to the 4th is the same as y squared. And then I'm left with the radical 5. So what you can see here is the same idea. They both have radical 5 to the same index. It's fine. But this second term is y squared. The first one is 12y, or is 12. I wouldn't ever just subtract that. I don't know what that is. But what I can do is factor out the radical 5 and make it radical 5 times 12 minus y squared. And then I can be done. All right, this is the end of this section. We will continue on in this module to the next section. I will see you there.